have here a reasonably level ramp, a cart, which will accelerate down the ramp as a result of paper clips suspended over a pulley at the end of the ramp. There's something uneven on the ramp, prevented the cart from starting when I released it. I'm going to smooth that out with my hand a little bit. There are also a number of paper clips on the cart. We'll see what the function of those paper clips is and why they're sitting on the cart in a minute. Now I'm going to release the cart, and we're going to time it as it accelerates from one end to the other. Now, depending on what you're using to time this, pendulum, timer, computer timer, or whatever, I'm going to give you 1, 2, 3 as I start it. Actually, I'm not going to do that. I'm going to say, let's use the computer timer and go with the sound. Don't anticipate. Don't look at what I'm doing. Don't look at the cart as it approaches the end. Time the thing with the sounds, not with any visual cues, because you can't anticipate the first sound here. You can't anticipate the release. You can anticipate the end, and that throws the timing off between the two events. Okay, so let's go ahead and time this. Okay. Now again, what we have is 3 paper clips suspended over the end. And we'll comment that the ramp is inclined so that the cart, when given a slight nudge, maintains a constant velocity down the ramp. Now we're going to do the same thing again. Okay, we want to see if the time is consistent. We want to test the consistency of our apparatus. Okay. Now I'm going to take one of the paper clips off of the cart and suspend it from the pulley. So now there are 4 paper clips tending to accelerate the system. We'll come back here, and we'll just do one timing on this one. And then we'll take another paper clip and transfer it. Now the reason I'm transferring paper clips from one end, from the cart to the hanging weight, is simply to keep the mass of the system consistent. So what we're doing is we're observing the acceleration for consistent system mass. So here we go again. Now there are 5 paper clips. Okay. Now we'll do a 6th. And we'll transfer a 7th. And an 8th. 1/10. Eleventh. Twelfth. 13. We just slipped off the pulley. 14. 15. What we're going to test here is whether the acceleration of the system is in fact directly proportional to the accelerating force. The accelerating force comes from the force of gravity acting on the paper clips, the hanging paper clips. The mass of the system is consistent. It's the mass of the cart plus the mass of the paper clips. So the analysis will consist of determining the acceleration for each number of paper clips, plotting acceleration versus the number of suspended paper clips. If that plot is linear, then we've confirmed that the acceleration of the system appears to be a linear function of the accelerating force, and in fact proportional to the accelerating force.